Hi everybody, today we're going to be doing the last lesson of Unit 5. And this first page is really just a review of everything you learned. And Lesson 4, you really learned everything you're going to learn for this unit. This is just one more time summarizing everything and trying to put it all together. So some of the common definitions that we use throughout the unit: a turning point, that's where the function changes in the graph. A critical number can happen where the first derivative equals 0 or it does not exist. Remember that does not exist came up when we had a denominator and we would have to decide where the denominator would equal 0 because that would cause a does not exist condition. The maximum is the highest point, the minimum is the lowest point. Increasing intervals happen where the first derivative was greater than or equal to 0. Decreasing intervals happen where the first derivative was less than or equal to 0. For concavity, we started looking at the second derivative. Less than or equal to 0 was concave down. Greater than or equal to 0 was concave up. And then lesson 4, we looked at points of inflection. So stationary points of inflection have a first derivative equal to 0 and a second derivative equal to 0. And that is a point on the function that is neither increasing or decreasing. If we look at the derivative, the slope of the tangent line at one of those points, right, we would get a slope of 0. That's different from a non-stationary point of inflection. It wouldn't show up when we take the first derivative and decide where it equals 0. A non-stationary point is only going to show up then when we take the second derivative. And in that case, at that point, the function will be either increasing or decreasing, right? So we have decreasing tangent line here and an increasing tangent line here. So we're just going to go through one example, just kind of go through it all one more time, make sure you're feeling good about it before you do some more practice. And we're going to take the first derivative. We're going to factor this, and we're going to set it equal to 0. We get our two critical values here, negative 15 and 2. We're going to do test values before negative 15, between negative 15 and 2, and after 2. And what I would suggest, and I probably should have said this right at the start of the problem, is to pause this video and try to do it on your own. And then, you can start watching it once you've given it a shot. Right, so we get positive 18, negative 30, and positive 18. So we have positive, positive, which we know means increasing, decreasing, and increasing. Where it says find all local minimum, maximum, and stationary points of inflection. So the function is increasing, decreasing, and increasing. So we have our general shape. So we know that we're going to have a maximum right here, and that's happening at negative 15. And then right here we have a minimum, right? And that's happening at x equals 2. So the coordinate, if we put negative 15 into our function, we're going to get, high value, 791.5. And if we put 2 into our function, we're going to get negative 27.33. So this guy is a minimum, this guy is a maximum. And I'm just going to highlight them right now because we know that those are the values that we definitely are going to want to plot on our graph once we get to the last box. find the intervals of increasing and decreasing. All right, this is easy now that we have our sign diagram all marked up. So increasing is happening where x is less than or equal to negative 15 and x is greater than or equal to 2. Decreasing is happening where x is greater than or equal to negative 15 and less than or equal to 2. Now, if you notice, we didn't see any stationary points of inflection. We have a maximum and a minimum. We don't have any situation where we went negative, negative, or positive, positive. So we know we don't have to concern ourselves with any stationary inflection points. We're going to take the second derivative now to take note of any additional inflection points we would find. So at this point, we would possibly be able to identify non-stationary inflection points. The second derivative is going to be 2x plus 13. We set that equal to 0. So we're going to get x equals negative 13 halves. We're going to test values before negative 13 halves. So negative 13 halves is negative 6.5, so I'm going to pick negative 7. All right, and negative 13 halves, a good value would be 0. It's always easy. So we get a negative value, we get a positive value, so we know we're concave down, and we're concave up. All right, so we have identified a non-stationary point of inflection. Let's write that in red because that's important. All right, non-stationary point of inflection, and that happens at negative 13 halves. And I'm going to highlight that because that's another very important point for my graph. Just to note, intervals of concavity here. All right, concave up, where x is greater than or equal to negative 13 halves, and concave down, x is less than or equal to negative 13 halves. All right, so my key values are going to be happening at x equals 2, x equals negative 15, and x equals negative 13 halves. So I'm going to plot all those points. And this graph is not going to be to scale, of course. No way to do that. And we don't want to waste our time doing something like that. We just want to see the general shape of the graph. All right, so those are our x values, and then the y values that we need are, let's see, 791.5 and negative 27.33. I'm going to plot my points and label them. I have a max at negative 15, 791. All right, I have a minimum at 2. Actually, let me do this. So I have a minimum at 2, negative 27.33. And then I have a non-stationary point of inflection at negative 13 halves. So a non-stationary point of inflection means I'm going to be either increasing or decreasing. I have an increasing or decreasing tangent line at that point. All right, so I'm going to sketch my graph. I'm concave down. I change concavity right here. And there's my graph. Right, so I'm concave down before negative 13 halves. We'll just make a note about that. So we're concave down. And here we're concave up. And I forgot to note, I just want to make a note here that this is a non-stationary point of inflection. All right, so the rest is up to you. You got to be patient, take your time, be careful, and enjoy it. Hope you have a great day.